Okay, so today is the second session for lecture series 5. We only got a small number of questions left. So let's finish them first. And then if you got any other questions related to the lecture or even the previous one, feel free to speak out. Otherwise, we can finish earlier. We'll see how that goes, right? Depends on you guys. Okay, so the first one here, your fellow students was actually having some question about using equal versus tilde on the expanded classes. So let me read through their insights and then I'll correct them in front of you, and then we'll try to just revisit the examples quickly. Okay. So first of all, when comparing two expanded classes, in that case, equal and tilde are exactly the same. In this case, yes. Okay. So whenever you say, for example, let's say, remember what we did yesterday. Whenever you do EB1 equals EB2, assuming that these are both expanded of the same type, for example, B1 or B2, right? That we talked about yesterday. In this case, it will be equivalent to by simply saying EB1 tilde EB2. Okay, just say a little bit more to it. So this is also equivalent to EB1 dot is equal, and then EB2. So this is always the principle. So you can think about calling equals is as if you call tilde, which is as if you call is equal. So now when you look at this particular item over here, you can think about that is equal here. There are two possibilities. So that's why you got to be careful. The consequence might be different depending on how you set up the classes. Consequence number one could be the default version. In the case of the default version, each attribute is compared using just the equal sign. And of course, the equal sign over here, again, depends whether the attribute itself is reference type, in which case equal will just be comparing their references. If the attributes are expanded type, in that case, you will just go through this definition again. So you can think about this definition here in some ways recursive. Okay, case number two, you will actually call it redefined version. In that case, the expanded class you are defining, you actually say inherits from any, but you redefine the is equal. So if you refer, I'm going to mention very quickly from yesterday. Okay, so yesterday we talked about B1 and also B2 over here, these two classes. So B1 actually does not redefine the is equal, whereas B2 actually redefine the is equal. So that means when you try to say B1 equals B2, it will be a little bit different from E3 equals EB4 because they are of different types, right? That's something I will talk about a little later. I'll show you something on the debugger as well. Okay, so that's about the principle I would like to start with. Okay, let's read through your fellow students' description further. Okay, let's say X and Y are instances of the same class. Okay, so they didn't really say whether it's expanded or reference, but let's read on. And within that class, there is some reference type attributes, for example, string or person or whatever, right? Something that's not primitive. There's a reference attribute called R, okay? And when we do X equals R, are we doing a reference comparison of all the attributes, which means we're going to say X dot R equals Y dot R. So now, according to the definition we just said over here, right, about the principle. So let's assume your fellow student really meant some expanded class, right? Let's be very careful. When you say expanded class over here, when you say that, in that case, in your expanded class, you actually got some reference attribute R. So now, whether you're going to do this or not depends on whether that's sequence consequence number one or consequence number two. If you actually talk about consequence number one, then yes, you're going to compare every attribute by using just an equal sign, right? As I said over here. And consequence number two, in that case, it really depends on how you actually redefine the is equal. Maybe in your is equal, you're going to compare this particular R over here by its contents using tilde. Or maybe you still want to keep the default version. So we don't know. So I would say it depends. So you can see the way I'm reasoning about this really depends on the principle over here. So you just need to know about these two general consequences, and then you want to see which one you want to go for. But my advice to you would be, if you decide for your lab number 3 or for your projects, if you want to make your own class, maybe either expanded or reference, you will, if you believe objects of those classes are going to be compared using tilde. In that case, you should always redefine the is equal. Like you should always redefine the equals method in your Java as well. Okay. Okay, and then let's read on. When we do x tilde y, we are doing a content comparison. Okay, so this one I would say not always. Not always, right? Because again, for situation number one, it's not the case, right? So for situation number one over here, since we're using equal always, so we might be comparing references. Okay, for situation number one, no, we'll actually say x.r equals y.r. In that case, we will be comparing its reference, right? What about situation number two? In that case, again, it depends. Because when you say x tilde y, we are really calling the is equal over here. So it really depends on how you redefine the is equal. Again, I'll say it depends. Okay, finally, okay, or is it the case that when we compare two expanded objects of the same type, okay, let's say B1 or B2, right? Depends. We're always comparing contents. When you say always, you gotta be careful. It is a very strong statement. When you say always, no. Okay, because for situation number one, you actually compare attributes using the equal sign. Okay, so not always compare just the content. Sometimes for reference attributes, if you're using the is equal, the default version, then they'll be comparing references. Regardless of the equal symbol, okay, so I already answered that. So even when we do x equals y, you will just do this. Okay, not really, no. Okay, for situation number one, it's definitely not the case. Okay, and for number two, again, you know the answer. It depends. Depends on how you customize the definition for is equal. So guys, if you haven't really get a chance to attend the session from yesterday, you can definitely go to, so I'm not going to show you. So if you go to the YouTube video from yesterday, I put the timestamps for each section there. You can maybe refer to the section in the beginning where I talk about the is equal, so that you will see more details over there. But now I'm just doing a summary. But I can see some of you actually were here yesterday, so hopefully you know what I'm talking about. Okay, any question about the very first question here? Any questions? Everybody is okay? Okay, we have quite a small group today, so please feel free to speak up. You know, I don't mind interruption. Okay, let's say go to the second one over here. All right, for the second one over here, there's something I want to show you about the is equal. Okay, there's something just as a reminder actually. Okay, there are two things I want to show. Okay, let's do the first thing. Okay, so let's say here, I'll do the illustration over here on the iPad, and I'll show you how you can experiment it on EStudio. So over here, you can see for B1 over here, we do not redefine the is equal, right? There's no is equal over here. On the other hand, for B2, you can see we redefine the is equal. So that means now, when you say EB1 equals EB2, if you do that over here, EB1 equals EB2. So it would be as if you actually say EB1 dot is equal EB2. Okay, and then you know that EB1 is of type B1. So we will be calling, you can see there's no redefined version over here. So that means going to call it default version. I'll show you in just a moment. The default version, which means every attribute is going to be compared using equal. Okay. On the other hand, when you say EB3 tilde EB4, of course, this is just simply equivalent to, because it's of type B2. B2 is also expanded. It would be equivalent to, if you say EB3 equals EB4, and also is equivalent to EB3 dot is equal EB4. So they're all equivalents right now. So now, which version of the is equal are we calling? So now, if you look at B2 over here, the type, so you can see that one there has already redefined the is equal. So that's why we're going to call this version instead. And for that version over there, you can see we are comparing the integer attributes using equal. That's okay. But we are comparing the reference attribute s, which is of type string. So now we are saying in this redefined version, we're using tilde to compare the contents, right? But that's why I said not necessarily you're always comparing the contents. When you say expanded type, when you use tilde, not necessarily. Sometimes maybe not. Right? It really depends. Okay, so the message from this particular slide, which I'm going to show you very quickly in EStudio. So depending on what the expanded type you're really comparing, so also depending on whether they got default version or they got the redefined version. So which version will end up being called at the runtime? It really depends on the type of the objects. Okay, that's the main point. Hey, let me just show you one more thing, and then I'll look at everything in the EStudio. Okay, one of your colleagues was asking about this question here. Okay, so again, we still got the same B1 and B2, the same setup. So you're familiar with the example already. Okay, so now I'm basically trying to do the following. So EB1, EB2 is of type B1, where we got a default version. Okay, again, just to remind you. So this one we got default version of EECS3311. EB3 and EB4, we actually got the redefined version. Okay, so now when you do EB1, it's not equal to EB2. We explained it yesterday already because EB1 and EB2, they have two different string objects. And the default version is only going to compare the two strings by reference. So that's why they are not considered as equal objects, right? So this will pass. On the other hand, when you do EB3 equals EB4, it will be true that they are equal because you're going to call the redefined version, even though their string attributes contain different values, but the contents are the same. So we're going to compare their contents over here, right? That's what we said yesterday. So now, one question I didn't really answer completely yesterday was this. What if we try to say EB1 equals EB3, for example? What's going to happen? Well, conceptually, it's really weird because you're really comparing apple versus banana, right? You're really comparing two objects of different types. In that case, we would think that you wouldn't compile. But it turns out the compiler will actually allow this. However, the result over here, when you try to compare, let's say EB1, let's say EB3, right? You can see the type for EB1 is simply B1. And then EB3 is of type B2, okay? If you try to compare these two expanded types, what's going to happen is it's just going to be trivially false at runtime. Okay, it compiles, but it's trivially false at runtime. It's not going to call any EECS. Not, I'll show you in a moment. Not calling any version of the EECS. Okay, let me illustrate 1, 2, and 3 all together with you. Okay, so later on, if you're wondering about whether your expanded class is really doing what it is supposed to do, you can always use the debugger to try to see whether the correct version of the EECS is being called. Okay, let me show it to you. All right. So if you go to the lectures page, let me just show you. I have set up already, but I want to show you how you can download the source code. If you go to yesterday was week number 5. And then you'll see one of the example I made available to you is the expanded class EECS and deep twin, right? The same example, okay? Just go there, download the source code, and compile in EStudio. And then, let me show it to you. When you open the project, go to this class called test expanded class, right? Go to the class. And then you'll see there are a number of test queries over here. Go to the first one, test expanded EECS over here, okay? So as I said before, you can see we got EB1, EB2 of type B1, EB3, EB4 of type B2, right? So now you can see, now the first one, we're comparing EB1 and EB2, which means we're going to call the default version from B1, the default version that's inherited from any, number 1. Number 2, for this one here, is going to call the redefined version from B2. And then the third one, which is something I didn't answer yesterday, but we're going to see that today. So you can see EB1 is EB1 over here is of type B1, and EB3 is a completely different type B2. It's going to be trivially false. Okay, let's illustrate that. The way to experiment this is like this. You simply just put breakpoint. Okay, drag and drop to the features tag over here. Okay, we learned about it in lab 0, right? So simply put a breakpoint in the very beginning over here. Okay, so what we'll do is we're going to pause at a breakpoint in line number 1, 2, and 3. And when we pause there, we're going to step into and see which version of the ESequal is being called. Okay, that's what we're going to see. All right. So let me just say run over here. Okay, so now the first one here, what do we expect to see? EB1 equals EB2. If we are trying to do this comparison, apparently it's going to refer to the version that's in B1. And that one there is simply just going to be a default version, right? Agree? So what I would do is I can simply say step into. So if I do it now, you can see even though it's showing B1, however, if you look at the contents over here, it simply says external built-in. So that means it's the default version that's inherited from any class, like an object class in Java. And what this comparison will do is exactly what I said before over here. So that's the default version I refer you to. So that one is simply just going to compare every attribute using equal. So that's something that's not really set in the source code and in the EStudio, but that's something you can know since I told you already. Okay, so that's about the first one over here. And then let me just go ahead and evaluate it, right? So now, according to it, it will be false, right? That's the correct answer, right? Because if you compare the two string attributes using reference, it's going to be false. Okay, so that's about the first one. Okay, so let's now move on. So step over. So now for this particular one here, so now we're comparing EB3 against EB4. So now we're going to call the redefined version from B2, right? So now if I say step into, you're going to see a different version of the ESequal. Used to be B1, but now it should be B2. If I say step into, you can see now we are in the ESequal of B2. You can see the context class is different. And then if you look at the definition here, it's simply going to compare I by equal, but S, the string value by tilde by the context, right? So that's what I meant. Whenever if you go to consequence number 2, the result really depends on how you customize the definition for the ESequal, right? So let me step over quickly. So now, very important thing to really look at now is something that your fellow student was wondering about during the Q&A yesterday. So now we got EB1 compared with EB3. EB1 is of type B1. EB3 is of type B2. They're completely different type. However, it allows IFO allows that to compile. Okay. So now I think this only happens for expanded type. For reference type, if you try to compare them with the different types, I think it will give you a compilation error. But anyway, so this is a special case. So now the question is, if now I try to step into which version of the ESequal is going to is it going to give to me? That's the question, right? First of all, let's try this. In the expression here, if I simply say EB1 equals EB3, it will just evaluate to false. But I wonder how the evaluation was done. Is it done by which version of the ESequal? It turns out to be neither. If I simply say step into, watch out what's going to happen. If I say step into, you can see it doesn't go into any routine. It simply skip and go directly to the result. That simply means there is no there's no ESequal query that was called when I try to evaluate this particular equal sign. So you can interpret that as it's simply just trivially false because we're comparing two variables of different types. Okay, so that's the complete answer to the question from yesterday. All right. Okay, so that's about the demo I want to do, but you can definitely try to really see if you can really reproduce this procedure here. Whenever you're trying to see which version of the ESequal is being called for your expanded type, you can definitely step into it and see what happened. Okay, that's the main lesson I want you to learn. All right. Okay, so that's about the second and also third question over here. I'm just talking about them in a single story. Any question so far? Is everybody okay? Nina got a question here. Does it matter if the class is expanded? Meaning that if the class is not expanded, equals compared by reference, what does it depend if, okay. Let's do a quick summary here, okay. So the summary will be kind of similar to the slides that you got for lecture number 5. Okay, let's based on what we have talked about so far. Let me just do a quick summary. Okay, so we talk about equal versus ESequal. Okay, so case number 1. Let's talk about expanded type since it's still fresh in your mind. For expanded, okay, for expanded class, so when you use equal, it's as if you use the tilde, and then it's as if you actually use the is equal. They're all the same. However, in the case of, so when you look at it is equal, there are two cases, right? It can either be the default version. The default version will be simply use the equal to compare attributes. Each attribute, and the attribute, if the attribute value is primitive, you compare their value. If the attribute is reference, you compare their reference, just equal sign, okay? And then number two, it will be the redefined version. In that case, we don't know what exactly the behavior should be, okay? Let me write it more properly. It would be a redefined version. Okay, so that's about the expanded type. Okay, so let's talk about the reference type. For reference type, for reference class, if you say equal over here, okay, so this one here is compared by reference for short. Okay, and then the tilde over here, okay, tilde first of all is simply equivalent to is equal. And you can think about this part over here. When I say the tilde is simply equivalent to is equal, it's the same case, right? It's a principle, right? Okay, tilde is simply equivalent to is equal. And then what cases do we have? Luckily, over here, we also got two cases. And the cases are exactly the same. And then let me write it down first, and then I tell you why I didn't really tell you in lab number 0, because it's kind of different from the default behavior for Java, okay? So now for the is equal, let's say you have a person class, you have a birthday class, you have a tree node class, right? If you simply use the default version, in that case, you will also use the equal to compare each attributes. And also, you might just do redefine. And the discrepancy goes like this, right? If you recall how things work in Java, for example, if you think about this particular case over here, that's why it's a little bit confusing, but since I'm telling you, hopefully it's getting better. So in this case over here, in Java, the default version, the default version, if you say object number 1 dot equals object number 2, right? Let's say object number 1 and object number 2 are in the same class, for example. In that case, if the class for object number 1 does not override the equals method, in that case, it will be just the same as object 1 equal object 2. Okay, so that's why you can see it's kind of different, different behavior. Again, it's a language choice, right? It's a choice made by the language. So you can think about the default behavior for Java will be you just use equal. But in the case of IFO, they're simply going to use an equal to compare each attribute rather than directly between the objects. Okay, so now I will give you advice over here. Okay, what will be the take-home message for this? The take-home message will be when you define a class, if objects of that class may be compared using tilde, right? Then always redefine is equal. Just to avoid the case number 1 confusion, because it's different from Java. All right. Okay, Nina, is that okay? I hope that's clear to you about the two types. Okay, I assume that was okay. Okay, very good. Just want to make sure you're okay. All right. All right, guys. Any more question about is equal, and etc. Okay, I think that this page really summarizes everything you should know. All right. Okay, let me go to the next one. Your fellow students was still a little bit confused about the export status for command versus constructor. They still got some confusion there. So I'd like to maybe just explain once more. Maybe maybe make it a little bit more straightforward for your fellow student to understand. Okay. Let's say I'm trying to simplify that already actually. So let's say this. So again, this is the same example from your lecture number 5. Okay. Let's say we got a supplier and also we got client number 2. Okay. If I say client number 1 over here, let's say, so that's the restriction for using make as a constructor, right? And then I'll put client number, I'll put over here, blue and pink. And the pink one, I'll put client number 2. And this is the export status for using the make as a command. Okay, so your fellow students would come. Your fellow students' confusion again was to say, in the context of client number 2, you will not be able to use the make as a constructor because it's only for client number 1, right? So that's why this line will not compile, and also this line also will not compile either. And I already also illustrated this to you in EStudio yesterday, so you can also review that part if you wish. And then the real confusion comes over here. If you think about this this line over here, right? If you think about this line over here, are we able to use the make as a command? The answer is yes. So as far as the use of the this qualified call is concerned over here, s.make, this is considered as okay. And as I said yesterday, if you also thinking about some issues related to voice safety, because if these two objects cannot even be created, how can we call a make on S, right? What I said yesterday was there are 2 stages, one followed by the other for the compilation in iPhone. The first stage is only going to check whether for every dot notation you're using, for this dot notation, you're using that as a constructor. And for this dot notation, using that as a command, like a regular call. So they're only checking to see whether each call in isolation, notice what I'm saying, in isolation, okay? Let me say that here. In isolation, this call is okay. And then voice safety will come the next stage. But since we already got 2 errors in the first stage, so we don't really move on to the voice safety check. So that's why. All right. So let's read through your fellow students' concern over here, and let me try to address a little bit more. Okay. Let's try this. So under the command version of make, there is a do end command, right? There's a do end over here. We cannot have do end for constructor make. Okay. So what I said yesterday was this will be invalid syntax. I think Jahao was the person who asked the question, if I remember correctly. So when I say creates and then make, you're only supposed to list identifier for the command over here. So if you say make, and also you put do end over here, so this is simply not going to compile. Okay, not going to compile. Syntax error. So under the create, you will also list IDs only, identifiers. Okay. Okay, and then let's go on. So does the constructor make just look up the do end from the command make, and then using that initialize a new supply object? I would say this part over here this can be one way you can think of it, right? Although it's really it's very oriented to how the iPhone compiler actually implements its own internal workings. So I would say, yeah, you can think that way. Although I'm not sure if that's really accurate. Okay. Okay, let's look at the real question here. How can client 1 initialize a new supplier objects when only client 2 has access to the command make? Okay, so that's a question, right? So let's now put client 1 into the context. Okay, So now if you say class client1, okay, I think will be a test. Let me just simplify the test a little bit. Okay, so under the test of type Boolean, and then, okay, like this. Let's say we still declare S to be a supplier. Okay, so now in this case, we can say creates S dot make. Let's say 5 over here. So first of all, is this okay? This should be okay because we are really using under client 1, we're using the make as a constructor, which is allowed by the export status. So this is okay. So that's no question about it. Okay. However, if I try to write the next line, if I say s dot make over here, I want to change the value from 5 to 7. Okay. This line over here is not going to compile because you're trying to use the make as a command. There's no create keyword for this line, right? So you're only trying to use the make under the context of client 1. However, it's only allowed for client 2 only. Okay, so that's a confusion. If you cannot even call the make as a command, how can you call the make as a constructor? So as I said yesterday, think about their really independence. Think about from the client's point of view, either to use the make as a constructor or use the make as a command. There are two separate privileges, or there are separate usages that you can have as a client. And how do you know if you have that privilege to use as either as a command or as a constructor? You have to look at the export status. Okay, so that's kind of the response I put on the Google Doc for your fellow students, right? So think about this, in order to do this, let me say this. In order to do this, there is no prerequisite that you have to be able to do this. There's no such prerequisite, okay? But how does IFO actually support this? Well, you can think about when they simply say, when you are trying to use this as a constructor, what they will do is the compiler will internally maybe try to look up the definition for the make, and then try to use it to really initialize the objects, like how we explained that in Lab's theorem. However, when you're trying to use this particular call, so they will see that you just cannot call the make as a command directly. Indirectly using the make when you are creating an object will be okay. So that's I think that's kind of the difference you want to make, right? So using this versus using this, they have nothing to do with each other. It all depends on how you set up the export status. Okay. And then I think for your fellow student, they were simply just trying to maybe have some conceptual how to say, have some conceptual mechanism about how this will work. So my response to them would be, you can think this way. You can think this way, meaning that when you actually list the make as a constructor over here, somehow implicitly that make over here also contains the definition for the do end. However, you do not write it explicitly. There's a syntax error. Okay. If you want to think that way, that's okay, right? Just be careful. You don't really write a syntax like this in your IFO projects. Okay. Okay, guys. Any question about this slide over here? If you still got confusion about using make as a constructor was a command, now will be the final time to ask for this section here. All right. Any questions? All right. Let me just write down one more thing in case I guess maybe your fellow student is not really here today. Let me just write one more note for them. Okay, this is one. Okay, and this is another one, right? Let me put the notes over here. Okay. Being able to use make as a command does not require, sorry, I meant to say being able to use as a constructor. Constructor, okay, does not require that you are able to use it as a command. Yeah, just running out of space. Okay, it's a final remark about this particular example here. All right. If no more questions, I'm going to move on. All right. All right. Okay. Okay. Nothing on the chat. Let me check. Okay, that's good. All right. So now there's another thing about. Okay, we only got two more. Okay, it'll be quick. And this one actually will be important. Actually, I'm glad you guys asked. So the question goes like this. We can avoid initializing the object as an expanded class, do it by default. Okay, I think what your colleagues really meant was, if I have a class like this, let's say the class is expanded. Let me just make it simple by just having integer attributes, right? Similar to what you got in your lecture. Expanded class, and then let's say A, okay? And then let's say over here, if I only have, let me give you a different version over here. If I got integer I of type integer, I of type integer. Okay, this is one version. Okay, let me give you the second version called B. Expanded class B. Okay, so these are all keywords. And then I would say creates, default creates. And remember, I talked about default create yesterday. So that's like a default constructor, as you saw in Java. So if you want to redefine the default creates, you know the syntax. You can see from B2. Let me just show you quickly. So I'm not going to repeat the details over here. So you will simply say inherits from any, and then redefine default creates, and then you can list the default create over here, right? But now I assume you have done that already, okay? So now if I say create default creates, and then let me just define quickly. Default creates is going to be, let's say do, let's say I is assigned to 5 and n. Okay, so that's the second version I have. Okay, let me just put it here. Okay, let me put the second version here. And then, of course, I also got the I of type integer, right? Just be complete. Okay, let me give you a third version. And then I think that will properly address your fellow students' question. Okay, there's a second version over here. Let's say the third version. Expanded class, and then C, okay? And now for under the creates, I can say default creates. And then let me just do another one. I can call it make, but to make just a standard name for constructor. Okay, so now over here, I'm gonna say default creates, let's say do, let's say I is assigned to maybe 5. I got another one, let's call that make. And the make maybe takes some new I of type integer. And then do I is assigned to new I. Okay, and then you can see that. Okay. Okay, you can see now we got 3 versions of expanded classes, right? A, B, and C. The difference is A is the minimum version you can have. You don't even declare create default creates, because if you don't have to put it this way, it's pretty much like Java. You only have to explicitly list default creates constructor if you got more than one constructor available in your in your class. If you only got default create that's available in your class, you don't have to explicitly list it. Okay, so now I would say implicitly is as if you said creates default creates implicitly. Okay, so now let's see what the difference is between A, B, and C. Okay, let me now use green. Okay. So now if I try to say object A of type A, object B of type B, object C of type C. All right. So now, without explicitly initializing the objects, implicitly it will be as if you say creates OA.default creates. In that case, since there's no default create over here, which means we're going to use the default version. In that case, it will just be 0. Okay. So now after this, okay, OA.I will just be equal to 0. It is because the default creates is not redefined. Okay, hopefully everybody can see that. Okay, and then what about OB? So for B over here, so it's as if you say creates OB.default creates, and for the default create we have already redefined that to be 5. So that's why OB.I will be equal to 5. What about OC? Similar, because you can see for OC here, default create is one of the constructor, but more importantly, it's actually default create has been redefined to also 5. So OB.I is equal to 5. So now the main principle is this. Implicitly, an expanded objects OBJ is initialized as creates OBJ dot default creates. I'm just writing that shortly. Okay, so that's always the default constructor that we are calling. So say create OBJ dot default creates. But now in this particular class C, you got more than one constructor. So how do you do it? Okay, you can say that, for example, let's say, let me just continue from here, right? When I say, so this should be OC, sorry. So this one here should be OC. So now let's say after this line over here, I'm running out of space, but you can definitely say, let me say this. Okay, let me just put it here. So now let's say after this line, I can put it here, okay? So you can still say maybe creates OC dot make, maybe 8. So that's what you can say. So now you're basically saying, I want to explicitly call this particular constructor, which is going to assign the I to be the new value, which is 8. Okay, so the main thing I want to say here is implicitly for any expanded object, you always call the default create constructor. However, after this very initial call, you may choose to also call other constructor for your expanded class, in which case you're just going to initialize maybe differently. In this case, you're going to call this particular constructor, which is allowed. In that case, you will put the initial value to be whatever that's assigned to the arguments, which is 8. Okay, any question about this slide over here? Any questions? Just trying to show you a variety of expanded classes you might define, right? And of course, so far we don't, for the classes you're given, you don't really define the constructor yourself. Normally we just give them to you. Maybe for your lab number 3 and for your projects, when you design your own classes, you can definitely think about you might have multiple constructors in your class. In which case, you will try to list maybe multiple command names under the creates. That's definitely something you can do. Okay. Okay, so that's about this part here, and then let's move on to the next one. Okay. Okay, finally, this is more like a repetition, but your fellow student was still having trouble of understanding this. I also responded to them on the Google Doc as already, but let me just mention quickly. Okay, so the question was like this. In your lecture slides, the way we retrieve for D1 and D2, so that's a singleton pattern. The way we did it in the lecture was I simply say, just if you can recall what we did. In the lecture, we said we only got a single access variable s of type data access. And then we say D1 is assigned to access the data. We're using this access object. And for D2, we also say access the data. That's basically from your slides, okay? But your fellow student was wondering, what if we try to change the context object over here? You can see one is access other, the other one is access. You're using basically two different access objects, right? One is access, the other one is access other. And they are both of the same type, data access. Is it going to make a difference? The answer is no, as we said yesterday. Let me just visualize once more, okay? Because after all, you are still calling just the same. You're just calling the same once routine, which is defined over here. You're still calling the same, so it wouldn't make a difference. You will still just return a singleton reference every time. Okay, let's just visualize once more. Let's do the first one. When you say access, data, right? What's going to happen is access over here is data access, which is expanded type. So you're going to simply just get data access, and then this is access, right? Expanded objects. And then if you look at the class over here, there is no attributes, but you can think about it does contain the definition of data, which is a once routine, right? And then also you're going to initialize the access other over here of the same type. So that means you got over here also data access, access other. And then this one here, we're also referring to the same class, which contains the same definition. Good. The definition is the same. Also, the definition of data. Okay, so that's about the implicit initialization. And notice one thing, if I draw some connection from the previous slide over here, so you can think about the bank data access class does not redefine the default creates. In this case, we don't have to because there's no attribute over here, so that's fine. Okay, just to remind you. Okay, so now let's try to see what's going to happen here. The first one, when you say access.data, right? We're basically calling the data here for the very first time, right? For the first call. So you can think about this is the first call. In that case, we're simply just going to execute the body of the implementation over here, which is going to make a new bank data. And that one will simply got some interest rate, right? So what you will do is you're going to create this data over here. So that'll be bank data. And then you have the interest rate, for example, and whatever it is. Okay, so that's the first object. And then you're going to assign D1 into this particular object. So D1 is going to point to this particular object, right? So that's this line. Let's try the second one here. The second one, you're calling access data using that as a context object. So now access data is actually over here. And then, oh, actually, when that was explained previously, when you say access data, you're referring to just this version, but it's the same version anyway. Okay, I just highlighted the wrong line. Okay, so now when you are actually doing this access other, so now you're really referring to just the same definition. So you're calling this for the second time, right? So this will be the second call. Well, if that's a second call to the same once routine, so you don't actually try to create any bank data object. You just refer to just the same object here, right? You can think about internally, implicitly, there's a cache reference kept by the runtime, which you don't have to worry about. So what we will do is we're going to say D2 over here is assigned to this particular data, right? It's a second call. So that means D2 is now also pointing to the same object. So you will still you still achieve singleton pattern. So if you really like, you can definitely try to use different data access objects, but it's not necessary. A single one is going to be okay because you are calling the same version of the once routine data anyway each time. The only difference is whether it's going to be the first call versus all the subsequent call. So that's the difference. All right. Okay, I think that would be the end of the questions over here. Let me do a final check. Okay, I don't see any question on the chat. I just want to go to the Google Doc. I just want to make sure I don't miss anything. Okay, let me just take a look. Okay, so I believe so far everything was covered. Okay. Okay, that one's covered as well. This one was covered. I think this one was covered as well. Okay, I believe everything's covered. All right. Although I see some people are maybe editing the documents, I don't know. But if you are, why don't you speak up if you want to? It seems that everything's covered. All right. Okay, guys, any questions? Anybody? What happens if a descendant clause calls the once routine? Does it still use the same object that was made? Yes, I think so. Inheritance is a orthogonal issue over here that shouldn't affect the outcome. So yeah, you're just thinking about the theoretical possibility, but in practice, I'm not sure what you would want to do it. But let's take a look anyway. Let's say data access, right? You know what? Let me just be a little bit more precise over here. Okay. Let's say expanded clause data access, and then you have your data over here, and then once, right? And whatever definition it is, okay, I'm just going to omit the details. Once end, and then end over here. So that's the expanded clause over here. And let's say we have a child class, as your fellow student suggested. Let's say this. Expanded clause let's say data access child. Okay, we should highlight this as well. And then let's say we don't redefine the once routine. Let's say we don't. Okay, so you simply say end. Okay, you might have some additional attribute as well. That's what inheritance can do for you, as we cover in this week's lecture. Okay, let's say this is just another class over here, and then we're going to get inheritance over here, right? So that's inheritance. Right, let's try this now. And assuming that we also got a data, right? The bank data class aside, okay? Let's talk about the clients. Let's say we got local over here. And then we have access 1, data access. Access 2, data access child. Okay, and then we also got data 1 and data 2. That'll be bank data. Okay, so this is basically the same setup. So now if I try this, if I say D1 is assigned to A1 dot data, and I say D2 is assigned to A2 dot data. Okay, like that. Now in this case, if you try this, when you say, okay, before, well, implicitly, both A1 and A2 will be initialized, right? Both of them. Okay, so let's say for A1 over here, you're going to initialize that to be, let's say here, right? A1 is going to be of type data access. And then for A2 is going to be A2 and also data access, okay? And then are they going to contain the same version of the once routine? Indeed, they will be, right? They will be contained the same. So you can think about this is one, this is the version that's going to be inherited to this version over here. So they will be the same, okay? So I would say definition of data and the same definition of data. So now let's go on to trace the code. So when you do the first one, D1 is assigned to A1.data, A1.data calling that the first time, right? So you're going to basically call this version over here, the body of the implementation. In that case, D1 will be assigned to basically just the first object that's first created, right? So that'll be bank data. And then when you do D2 is assigned to A2.data. A2, even though it's a child object, but inherits this once routine verbatim over here. In that case, the definition of data will just be the same. Okay. In that case, you're going to actually get just the same object, right? It's a second call already, right? So this is second call. And then D2 is pointing to the same bank data. Okay, so responding to your question there, it's actually going to be the same effects. Okay, does it make sense to you? Very good. Okay, let me say, okay, Robbie got a question there. Robbie, let me get back to you a little bit in just a moment. Okay, one follow-up question there, which can be tricky. Okay, you may want to try yourself. Okay, but this is tricky, I can tell you. I was being very careful about saying the same once routine is inherited verbatim to the bank data to the child objects over here, the child class, right? No redefinition. You may want to think about a case. Okay, we may not have time to set it up today, but if I got time, I can set it up. Maybe later you can bring it up in a future Q&A session, and then we can try it out yourself. You may want to say, for example, okay, how about this? This can be a potential exercise for you to find out what the answer would be. Okay. Exercise. Okay. So now what I want to do is, let's say rather than inheriting just this version verbatim, let's say we create a different version. Let's say we also say data. Let me just be more careful here. So now what you want to say is redefine. Let me just put in a different color. Redefine the data. And then we say data over here, and then once. And then you put something else, basically, right? You can think about this is one version here, and this is another version, okay? And then end. So now the question is, if now we do D1 and D2, are they going to get the same objects? That's the question, okay? Question, still the same objects, question mark, okay? I will encourage you to try to really find it out, explore yourself. However, I would say that this is not something you would like to do to instantiate the singleton pattern. So this is just something that will be allowed by the syntax and also by the type system. But you may want to try to see what the consequence might be. It might be of your interest to find out. Okay, that'll be an exercise for you. So for Amir, redefine is only for commands and query. That's correct. So now we are just redefining this query over here. So, oh, you know what? This is really a query. Data over here, I forgot to put it. Data will be bank data. And also the data over here will also be bank data. Okay, let me just put it. Yeah, I forgot. So what we're doing over here is really to redefine the query that's inherited. So we are doing it, right? Okay, let me get to Robbie's question. Robbie is still having some issue about understanding why and when we should use the singleton pattern. Okay, basically, think about you will use the singleton pattern if you want to share the same object instance. Think about, okay, let me just give you one concrete example, which would be relevant to your lab number 3, for example, right? That's something I'll try to elaborate a little bit further tomorrow during the Q&A. But let me just mention that quickly, okay? For your lab number 3, you're basically doing undo redo, you know, for the game, right? So think about the ETF architecture, assuming that you have already studied the materials. I mean, the ETF tutorial, that's quite important. Otherwise, you may not be really following what I'm trying to say. We got one cluster over here. So there is one cluster called user commands. Okay, and then let me just give you, I mean ETF, right? So if you, according to your lecture, you actually got ETF command. So let me use the example that's in your bank account objects, for example, right? So let's say you got maybe one class called deposit, ETF deposit. Deposit, let me just have another one, maybe ETF withdraw. ETF withdrawal, okay? And then remember, we actually got a client-supplier relation to the model cluster, right? So this is basically the model. So let me just draw the complete picture, and then I'll tell you why Singleton Pattern could be useful. Okay, so that's the model cluster that we have. Okay, let me move. So this is the model cluster. And then the entry point will be the model class. Let me just say ETF model. Or maybe even better, let's say you have already renamed it to bank. Okay, and remember there was a singleton access to the bank, right? You can think about the bank here is like a bank data. So you also got another class over here called bank access, let's say. Bank access, and that one there is going to return the once routine, right? So that one there is really over here. Well, I'm not sure how you're going to call that. Maybe you just call it bank, for example, or B. Okay, let's say, for example, right? And don't forget, typically we just say bank access should be an expanded class. So that is why for the ETF command, the way for you to retrieve a bank is by using the bank access over here. Let me be a little bit more precise over here. Okay, over here. Okay, that's kind of the architecture you saw in your lecture for the ETF, right? This week. Well, for week number 6, and also from the ETF tutorial. Let me tell you why Singleton Pattern could be useful over here. So think about, let me zoom in this particular class over here, okay? If you think about it, in the ETF command class, you will see. So Robbie, I will definitely explain that, but I will just also draw your attention to the following slides quickly, okay? So if you go to the ETF lecture number 6, right? Maybe you will get there maybe at some point. And then if you go to over here, I think around here. So that's kind of the diagram I mentioned over here, right? Okay, that's one thing. And then if you go to the iPad notes, you will see that I also try to explain how the singleton work, but I will repeat again. You can see this is actually the architecture over here. And then this slide here basically tells you that ETF command, you actually declare the model, and then you also try to get a singleton access to the model, right? So that's something you want to pay attention to. Okay, let me just explain again on the iPad. Okay. Okay, let me just move the web page away. Okay, let me just say here. Okay, for the ETF command, in this particular class, this is how we define that, right? You will declare model over here of type bank. Okay, so that means you are referring to this particular bank class. And then there is a make command. And the make command is going to become the constructor for ETF deposit and also ETF withdrawal, right? It's going to become that, okay? So you're going to have the make, let's say this. If you have the make, and then you got local over here, and then you got bank access. And then do, okay, this one should look very familiar. That's exactly what we have been doing, right? So now you want to say model over here is assigned to BA dot B, let's say. So Robbie, I hope so far it makes sense. That's kind of what we said in the tutorial so far, okay? So basically, this is saying that every time when you are creating an instance of a command object, like either ETF deposit or ETF withdraw. Okay, think about this. Let's say I first create, let's say in my acceptance test, I say deposit something, okay, and then followed by maybe withdraw something else. Okay, let's say this. Think about this is the very first command in the acceptance test. That's the very first one. So what that will do is it's going to actually create an object of this type, ETF deposit. In order to create it, you have to make use of the make that's in the common ancestor over here. And that one there is going to retrieve the bank data objects. And now, since this is the very first command, you're going to call this the very first time, right? Again, we're going back to the same logic for Singleton pattern. So deposit, what that will do is it's going to create a bank object over here initially, right? So the bank object over here, and then whatever attribute it will be, right? The same, okay? And then you can think about, you will also, at the runtime, you will also get maybe an ETF deposit objects. Deposit object, one of the attributes is the model. And that one there is actually going to point to this bank objects, right? So now, Singleton pattern will be extremely important because if you don't have the Singleton pattern, i.e., if the bank data access, if the bank access is not going to be a once routine, in that way, you're going to create not just this bank objects, but also many other bank objects. In that case, you're not really modifying it consistently the single bank data objects, right? That's kind of the idea. So let me just do one more. So now, if you try to do, let's say, maybe blue. If you try to call the second one withdraw, what that would do is it's going to, again, create a ETF withdraw objects. And then that one there also got a model attributes over here, right? So now, that one there, withdraw, is basically also a subclass of the ETF commands. In that case, it's going to retrieve the BA.B again, right? Given that it's actually a once routine. So now this will be the second call. Think about this is the second call. Or the subsequent call to the first call, to be more precise. In that case, you're also going to retrieve just the same object over here, just the same. So that means this is also going to point to the same objects. So that means every time when you want to do either deposit to maybe change something, and if you want to do withdraw to also change something, you're really modifying the same bank. You're not really duplicating multiple banks, in which case you're not really being consistent about your updates. So that would be why Singleton pattern will be useful. Okay, and let me go a little bit further to say for undo redo. Okay, in order to do undo redo, which I will speak a little bit more about it maybe tomorrow. For undo redo, you're going to create maybe some hierarchy over here as suggested by the chapter 21 that you're supposed to read for your lab number 3. So once you have created this particular maybe subcluster of all the use of all the commands for undo redo, what's going to happen is at the runtime, you're going to have a history, like a linear collection of commands history. Okay, each one of them is going to contain the command for the abstract events over here. For example, the first one is going to be deposit. So I'll just put deposit over here. And then the second one is going to be withdraw. And the second one is going to be withdraw. Okay. And notice one thing here is I also emphasize that in the instruction. When you say the deposit over here is actually very different from the ETF deposit over here. So this one over here is a user command, right? And this one here is something that belongs to your model cluster. So they are different, right? Don't just don't get confused. Okay. Okay. So now in the history of the commands, you got deposit, you got also withdraw, right? One thing that's really important is for each one of them, you also got another attribute called model. I'll just say M over here. You also got another attribute here called model M. And then the way it works is again by singleton. So there should be something very similar to this in your cluster, subcluster over here about the undo redo. For every command over there, they should also refer to the model, the single model that's actually over here. They should also refer to it. So to recap, basically what you have is this. The ETF deposit is referring to this object here. The ETF withdraw is also referring to this object over here. Deposit is also referring to this object here. And also withdraw is also referring to this object here. There's only a single bank that actually that's here, right? Okay, Robbie, hopefully you got it, right? It's a long answer to your question. But I will try to give a little more programming details tomorrow when we talk about Lab 3 Q&A. Okay? Okay, any other questions? Okay, I will pause maybe a little bit longer to see if we got any more questions. Otherwise, we can finish earlier today, right? Yeah, I think we cover all the tricky issues about export status and expanded types. I think you guys' question really make it complete, so that's good, right? So guys, no questions? Can you ask about the lab? Yeah, if that's brief, because I'd rather handle all the lab questions tomorrow, but you can ask, go ahead.
I just want to ask like a simple, for example,
yeah.
If I want to do like all the work on my machine, I did everything on the remote lab, but is there any way where I can, for example, just run it through my machine? Like I tried I tried like zipping it and moving it to my normal machine, but it still does not work because we need to use the Oracle.
Yeah. So do you have, okay, so it's a technical question here. So yeah. Do you have, did you say you use remote labs or you didn't use it?
I used remote lab, but I prefer to work because remote lab is slow. So I want to work on my machine, but I cannot run Oracle in my machine.
There is one solution you can try. Okay, so maybe I guess maybe your fellow student might be interested in this too. Okay, so now let's say assuming that remote lab is really slow for you, this is what you can try. Okay, so let me sketch that a little. You can try as well. The command I would suggest is called SCP. I'll talk about this in just one moment. I'll give you the conceptual idea first. You can try it out. This one, it may not be as nice as, let me see this. Are you using GitHub?
No, I'm not using it for this lab. But
you're not really using it for this lab. Okay. Yeah. Okay, so now, assuming that remote labs is not an option for you, okay, that's fine. And also, let's say GitHub is also not really set up for you, let's say. Okay, that's the assumption. But you do know how to use FTP to really transfer the file, right?
Yes, yes.
Okay, good, very good. Okay, so I think actually you may not even need SCP, I would say. Maybe even SCP is not necessary. Let's say this. Very easy. So let's say this. Let's say this is your local machine. Are you using Mac, Windows, or?
Mac, yeah.
Okay, but I think for Windows, you can also use terminal. Let's say local machine. Let's say you're building on your projects and also EStudio, etc. Okay, that's fine.
Okay.
And now, I would say the following. Okay. Basically, you're just replacing the GitHub components I said in the tutorial video by FTP. That's basically what you have to do.
Okay.
So every time you want to, let's say you have done something here, you want to upload the changes to the server so you can run the Oracle, from the Linux. What you would do is you're going to basically say FTP, right? SFTP, basically, right? And then let's say this part here is the REST server. Okay, the REST server over there, also you got a copy. So this is a copy of your entire projects. I think that every time maybe you can simply just delete whatever the old copy is entirely and then just upload the new copy there. It wouldn't take long because your project is not so big. So that should be okay. So far so good?
Yes, yes.
Okay, very good. So now, since you're using Mac, so I will mention quickly, for the Mac solution, you can simply just use terminal. And I think for Windows, you can use a tool like a Putty, something like that, okay? So let's say you're using Mac, right? Imagine that this is your terminal, okay? So I think the command you will use is something like that. Oh, you know what? I can show you right away, actually. I forgot, right beside my computer. Okay, so let me just show you. So guys, if you're using Windows, don't worry. You can definitely use the Putty to do that as well. Okay, I'll show it to you. Okay, so So let's say for example, assuming that you have already FTP everything to the REST server, assuming you have done that. So what you got to do is you would say SSH your student account. For example, my student account is sjackie@red.eecs.yorku.ca. That's what you can do, right? Just replace sjackie here by whatever your EECS account is. And then it's going to ask your password over here, okay, like that. And then what you will do, and then the rest will be very straightforward. I think I stored that in 3311 F20, let's say wherever you store your file. And then if I go to lab number 3, so now assuming that this folder has been already FTP by the latest version from your local machine already. So what you can do is you simply go into your project folder, and then you can simply run the regression test. That's what you can do. And then you can simply hit etf test.python. And then you can run it. So Nora, does it make sense to you?
Yes, it
okay.
does.
I think, yeah, so because the idea will be every time you want to debug or you want to do something in your EStudio, you always do it locally. So you only have, well, it's really a matter of how you upload the project to your REST server. I think FTP definitely works. You just cannot do it like a file by file basis. You're going to replace the entire folder. But if you got GitHub to set up to work for your project, it might be a better solution. Yeah, anyway, it should work.
Thank you. Yeah, perfect.
Very good. Okay. Yeah, so Amir, I think you said that to really developing on your machine, yeah, for sure that'll be much easier and also faster. But I would say in order for you to do regression testing, which will be very crucial for your lab 3 and the projects, because the Oracle is only available on the on the Linux server. So I'm afraid you will have to use maybe the solution I just showed to Nora, just about using SSH into your Red account and run the command line from there. So it should be okay. I think if you simply just run, there's no way to run Oracle on your Mac. No, we don't have that executable. The Oracle executable is only on the Linux. That's the only one version there. Okay. And then, so if you actually try this version over here, just using SSH, in that way, you don't really have to make any connection to the remote server. There's no GUI involved. In that case, I think it's much faster. You shouldn't suffer from any performance issue. Given that you just want to run the test, so it shouldn't take too long. Okay. Okay, guys, I still got 10 minutes before my office hour. Do you have any questions? Everybody's okay? Okay, I guess for many of you today, if you are interested in attending the Q&A session tomorrow, but if you cannot, don't worry, I'll record the session as usual. If you haven't done this yet, I would suggest you try this, okay, before tomorrow. That will be the assumption I will make tomorrow. I will show you what it is. So give me one moment. Let me just go to the e-class page quickly, and then I'll show you what you should do before tomorrow. That's the minimum you would like to prepare before gaining enough from me tomorrow, okay? If you go to your e-class, and then you will see under lab number 3. Okay, lab number 3, and then the ETF tutorial, I suppose many of you have started already, but this is the one called a starter tutorial. I want you to follow this particular starter tutorial over here, this one here, right? That one takes about less than half an hour, but that one will really make sure you set up everything on the remote lab or the remote server. So I would say maybe try to do at least that before tomorrow, okay? Okay, if no questions, then I will say we'll finish 10 minutes earlier today. And then if you got personal questions there, come to my office hour. Otherwise, I'll see you maybe in the Q&A tomorrow. All right? Okay, take care. I'll see you later.